we're not talking about within 10%.
Yeah.
We're talking about thousands of acres off from each other.
Welcome to another edition of the 21st Century Engineer, a podcast designed to help professionals in the civil infrastructure profession to grow, to look at new perspectives, to accept challenges, to make them leaders in a society that needs civil infrastructure desperately. We have a very informed, very interesting, very committed guest with us today, Dennis Lambert. Dennis and I have known each other for some time now, uh, working in the water resources area principally. Our involvement with ASE in various directions, and on a project that I thought was interesting enough to ask him to come in and share his greater depth of knowledge than I have about the Mid-Barataria Sediment Diversion System that has been kind of an on again, off again project. It's been heavily debated, uh, questionably thoroughly debated. And that's kind of what we're going to talk about today. Dennis, welcome. Thank you for spending time with us today. Uh, how would you like the audience to know you? What's your personal introduction? What's your 25 to 50 words as to who Dennis Lambert is?
Yeah, well, I'm a civil engineer, and I'm I'm 60 years old, so I think about my career and going back. My family has been in construction for several generations, and mostly road and highway type construction. And then it evolved into engineering. We have about a half dozen engineers in my family that are active here in Louisiana.
Wow.
And I went to LSU and I left. I needed to, uh, let me go back. I'll say that I started my working life in construction from my uncle. My father's one of 11, so he's on the state licensing board in Louisiana. He's been on it for 50 years. And he and his brothers all worked together, and they all worked for their dad and their dad's dad and that kind of thing. So when I went back home, I went back onto a construction project. The first one was an interstate ramp, and the second one was a pump station. And then I went to Tulane, and I worked my way through Tulane, and I got a civil engineering degree. I focused on concrete mainly, and then they started environmental engineering, and I entered that program as well, and I focused on water quality. And then I got a master's in environmental engineering, and I focused on numerical modeling and methods.
Mm-hmm.
And so that that was a in and out. Uh, I guess one of those things that I had to work, I had to go in, I had to go out. In school, I was not in the mainstream of education, but I don't regret any of it because I think that it was all part of where I am today.
Sure.
And then I would just say that the other part about my family that's interesting, and I didn't really know this until I was studying for an exam. I had looked up the family history, and it turned out my great grandfather, his name was Lucius Place. He was a merchant in Louisiana, born in Vermont. He got to New Orleans in the late 1830s, and he married his partner's daughter, who had gotten there earlier. And his partner was they were commission merchants,
Mm-hmm.
and he was from Pennsylvania. And they anyway, his wife died of yellow fever, and the city was surrounded by swamps, and
Right.
so they wanted to drain the swamp, and so they had debated that. And one of the ideas was to divert the river into the swamp. and elevate it with the sediment out of the river because they would see crevasses. And then when the river would recede back into the bank, they would have a lot of sediment deposited.
Yeah.
And so, and he also, anyway, he was the president of the second draining district, and they bought a dredge, and it was named after him. And he dug a lot of the canals that are still out there today in New Orleans, the London Avenue Canal, the 17th Street Canal, which are the canals that failed
Yeah.
during Katrina, the Orleans Avenue Canal.
But we're not going to
And
blame
then,
your relative for that.
yeah, it was a different time.
Yeah.
And of course, the lake was almost like another world away from
Yeah.
living in the city at
Right.
that time. It was a steam powered dredge that dug, it had like a 2.5 yard bucket on it. Anyway, fast forward, I live in my great grandparents' house. My
Yeah.
great grandfather was his namesake was Lucius Place. Levy, he was born, he was Jewish, but he converted to Episcopalian, and he changed his name to Levy, which Levee, which we know is
Yeah.
uh, ironic. And he started the Flood Protection Association in Point Capee Parish. And the reason why he started it was because they wanted to divert the river over his land. This was after the 27 flood. And so that it was in the 1928 flood bill, and he opposed it. And he and a bunch of other landowners opposed it as well. And they wrote letters to the government, to the engineers and all the congressmen, and they stopped this floodway from diverting that water onto the farmland of Upper Point Capee Parish and the parishes above it. It was called the Buff Floodway. And they ended up, one of the big landowners agreed to an easement for the Morganza spillway. And that was the LaCour family. And that is, of course, there today. And that easement allows the government to flood that property. It's like a deed restriction.
Right.
So that's just a little personal note. I still have my great grandfather's typewriter that he wrote all those letters on. It's in the old house that I live in. And so Mid-Barataria, you know how life is. I just was going to, I was involved in the projects off and on for 20 years, but I just to just to footnote this, I went to a church that the parish president went to. It was a happenstance. It was in downtown New Orleans, in the area where my third great grandfather grew up. So I kind of related to it, and I would talk to him about these diversions. And he finally opened up and he talked about how opposed he was and the parish, the people that elected him. And I told him to write a letter. It was kind of, I guess, an intuition that's been passed down. And I said, write a letter, ask them to come to your office and discuss it. Anyway, that started another letter writing campaign by, I guess, me as a member of our family, and I participated in. But anyway, I don't want to get ahead of myself, but I do want to share
Well,
that
it
history.
sounds like your relative was channeling through you um, from an
Possibly,
early point, and
yeah,
maybe it's a good thing that that was the case, or certainly it provided a perspective of uh, the fact things could change. That things being planned don't necessarily mean things being constructed, and that
right,
sometimes vision has to be re-inspected or reevaluated. We have to look at things from multiple angles. A lot of people don't understand. In fact, I imagine a lot of people in the country, let alone listening to the podcast today, don't know what Mid-Barataria is about, where it even is.
yeah,
Could you kind of give a thumbnail
yeah.
of what the project, where it is, what was about, what was happening, what was the theory behind what was being proposed most recently for this sediment diversion project?
Yes, it's canceled, and
Right.
what and it was a very large project, uh,
Billions of dollars.
more than 3 billion,
Yeah.
and the cost kept escalating over the lifetime, the projected lifetime of the project. So the theory, so the sediment load, the suspended sediment load in the Mississippi River has been significantly reduced over the last 100 or so years, going back to my relatives when they were in the city.
Right.
Uh, they there are studies that estimate between 1850 and eight 1980, something like that, that it lost about 80% of the sediment load, and that from 1980 to about 2015, they lost another 50%. So you ask yourself, why would they want to divert it if it's for land building? Well, that sediment, that's suspended sediment, and that sediment is trapped in all up above St. Louis, mostly on the Missouri River, from locks and dams. So
Right.
that the lock and dam system is like a stair step down, and it holds the water back so that the river's navigable. But what it also holds back is sediment.
Right.
And of course, that sediment is restrained to the banks of the river anyway. So that was the whole point, was to open up the levee and through a control structure like a tainer gate, which are very common. I live, as I shared, in my great grandparents' house. It's about 10 minutes from the old river control structure, which they have several different types of structures. One is a tainer gate system, one is a lift gate system, and one is what they call an overbank. It basically is a spillway as well.
Yeah.
And they also have a lock. Um, but anyway, and it has miter gates. So they have every kind of
Ooh.
navigation flood control gate in that complex, uh, right there by my house. And it is fascinating to go look at it. And that's what they wanted to do down there at Mid-Barataria. Now, what sediment are they diverting if it's so much sediment is lost in the water column? Well, it's primarily the movable bed is what they were going to want to divert, which is what goes into the Morganza spillway, outfall. And whenever they open the spillway and it goes through, as you know, into the Mississippi Sound, we'll talk about all that. But when they shut it, there's a bunch of sand, and they allow people to go in there. Sand truck drivers
Right.
go in there and mine the sand out of there,
Right.
and it's significant. It's not insignificant, but it takes a lot of river to move that material, and that's why the thing's so big. So that's really the theory behind it. The project diversions have been talked about going back to 1860. People's talk about they've been talking about it since, the 1980s or maybe even the 1970s. No, they've been talked about going back to the original citizens that were Americans that came in after the Louisiana Purchase. And it really is not an old. It's an it's really not a new concept. It's an old agricultural concept. What if you look at history? The Egyptians did it. The ancient Chinese people did it. In England they did it. They divert the river
The Mississippi
for
Delta.
cultivation.
Yeah, the Mississippi Delta
Well,
is built on that concept of replenishment as a result of flooding and
yeah,
diversions.
it's not new. And
Yeah.
there was a plantation down in Plaquemines Parish called the Orange Grove, and it was owned by the Morgan family, and that's what they did. Whenever they had trouble with the cultivation of their crops, they opened up the river, they flooded it, they had a little levees, and they trapped that water. It settled out, and then they released the water, and that replenished their fields for planting.
Right.
So it's an old concept. So anyway, that's really where it came from, it was a legacy project called Myrtle Grove, which I worked on. That was part of what the Corps of Engineers had the Louisiana coastal area federal authorization, and it was originally called the Delta Building at Myrtle Grove, and then it became medium diversion at Myrtle Grove with dedicated dredging. And then it was being developed after Katrina, which today, of course, we know is the anniversary of Katrina, and it really the whole issue of the coastal crisis in Louisiana was spotlighted as a result of Katrina because we lost so much land.
Right.
It made us that much more vulnerable. Um, and so that project was accelerated, and it maybe too much, maybe too supercharged, supersized, and not, you know, they were too ambitious, if you would.
Yeah.
And that's what we'll talk about.
Yeah. So the idea was to try and divert sediment that in many cases wasn't in the water, and what sediment was in the water was already being moved in a different direction, and the whole goal here was to try and reestablish, replenish land in that area of Mid-Barataria
Right.
by
And
moving the Mississippi over into that area.
tidally active land. So
Yeah.
it's a wetland that's going to be right at the surface level. So it's not really, and I have to say, going back to the 19th century, they used to call it the shaky prairie. It was never really stable land.
No.
It was always a wetland was that moved. And so, just like the river, whenever the river moved, they talk about delta building. You're either in the building phase of a delta or you're in the decay phase of a delta.
Right.
So that's natural too, to have decay in a delta.
So what would have been if things could have worked the way they hoped they work? If this project had moved forward, what would the outcome theoretically have been? What were they hoping to achieve?
They wanted to rebuild the wetlands in the outfall. They had projections. They used several different modeling platforms to illustrate that it could be possible to rebuild these wetlands. One was the Delft 3D modeling platform, was developed originally by the Delft University Hydraulic Institute. It became Deltaris is the name now, and it used to be proprietary. You would have to pay a license for it. Now it's open source. So they use that model to create what they call the basin-wide model. And it had originally been developed as a basin-wide model as part of the Mississippi River Hydrodynamic Delta Management Study, which was under the Corps Louisiana Coastal Area Authorization. It was about a $25 million modeling project. And they were looking not just at the river, they were also looking at the delta. And the Delft 3D model was used in the in the outfall area, the basin side of the study, and they used the Corps' traditional riverine model, HEC-RAS, for within the river. They used other models too,
Yeah.
but at like many things, we want to ground truth our models. Sometimes we run multiple models, different model platforms, and and that helps you have more confidence if you're getting the same answer. Well, that was not the case with this project. Under the Mississippi River Hydrodynamic Delta Management Study, the Corps ran its model called ADH, and that was out of Erdic. And it had a different land projection than the Delft 3D model by orders of magnitude. We're not talking about within 10%.
Yeah.
We're talking about thousands of acres off from each other. I'm not saying one was right and the other one was wrong.
No.
I'm just going to tell you, originally they were roughly around 20,000 in the Delft 3D, and the ADH was roughly about 7,000,
Acres.
okay, acres.
Yeah.
And then what happened was they abandoned that study. They pulled out of it, the state did, because when you're under a federal authorization, you have to run a benefit cost analysis, which is what I do today. And I didn't get into that in my intro, but I've run thousands of BCAs for flood mitigation. And basically, you look at all the benefits, you try to put a valuation on that, and you look at all the costs. And there were some concerns about whether it would be cost effective, which means it has to be greater than a 1-to-1 benefit cost
Mm-hmm.
ratio. So and there were other issues, but they ultimately pulled out of that study. And they filed, it was going to be a programmatic type permit. Um, they they filed for an individual Clean Water Act permit, and they started the EIS after they pulled out of that study. Um, and
Environmental
during the
impact
EI,
study. Yeah.
during during the EIS, they ran another model, and it was a HEC-RAS model on in the outfall using the sediment transport module of it. And and that was right around 2022. And these were different modelers. So you always have these different modeling teams. And it also showed disparity in the projection of land building. And I think that is what has triggered, the ultimate demise of this project. But I'm just going to share with you that when you have disparity, you have to be grateful for that,
Yeah.
and not try to avoid discussing it, because it and that truly is what we call the scientific method. We got to question our own results.
Well, going back to the first example, or the initial example you gave of 20,000 acres versus 7,000 acres, at the end of the day, these are models. These are mathematical equations, algorithms. For those of you in engineering, this is why you take differential equations. And it's all centered around a set of constants that predict exchange rates, transport rates, sedimentation rates. And these constants are based on specific applications that may or may not apply to the situation to which the model is being adapted. And so
Correct.
the disparity simply means you don't have somebody doesn't have the right constants. Or maybe nobody has the right constants. And the
Right.
value could be a lot larger or a lot less than what the two models are projecting. So the correct answer, as Dennis is suggesting, is you come in and try and figure out what's wrong.
Right.
What numbers did we pick that can't be justified for this application, instead of saying, oh, we like this answer better, so we'll ignore what the other model did. So
And better yet, so we, as you, when we, right around the time you and I met in 2018, the Corps of Engineers opens up the Bonacary Spillway. Then they open it up again in 2019. They've never
yeah,
opened it up back to back, right?
yeah,
Then they opened it up a second time in 2019. They've never opened it two times in a row in one year.
right,
And then they opened it again in 2020. So there we were. We had an analog, a real life,
right.
right in the middle of the EIS. And they could have run a model to try to match exactly what happened, not just the sediment transport in the outfall of the spillway. Even though it is a flood control structure, it is the same river, and it has an invert of minus 20, and the diversions have an invert of about a minus 40, and
Yeah,
it's a restoration project.
yeah.
But there are parallels that you can make, and then you can look at also what it does to the actual estuary, which
Well,
is the other
yeah.
part of this.
And in those diversions, for those of you that didn't grow or live on the Mississippi Gulf Coast, what we're talking about is toxic algae blooms, nutrient overloads, water use restrictions, destruction of marine habitat, closure of the oyster reefs, and a number of other things that could be mitigated. It's simply a matter of having to wait it out and let Mother Nature get back to what it was used to being as a result of having been inundated with all this fresh water. So,
330 plus dead dolphins.
and yes, yeah, the
And
marine environment was wrecked as a result of that.
totally.
Yeah, and
It's
but
it was a hurricane.
economically, Mississippi paid a price for that, as
Absolutely.
well as the environment along the Mississippi coast paying a price for that
Right.
diversion.
It's like a hurricane underwater, and nobody wants to go into a hurricane zone.
Right,
So after everything's devastated, people are suspicious of just eating the seafood,
as they
and
should be.
it's one of those things that happens. It's optics aren't good for when you have that kind of kill off.
Right. Well, I mean, we've both been through Katrina. Again, as you mentioned earlier, this is the 20th anniversary of Katrina, and I was on the coast a month later doing inspections of civil infrastructure along the Mississippi coast, and the just the gross devastation, but the materials that had gone off coast. Excuse me, the amount of material that had been dumped off the shore. Um,
Yeah.
yeah, it is, and this is another example. So, okay, sorry, I didn't mean to divert, but a little bit of additional color and perspective. So in effect, the diversion in 19 and 20 gave a pre-taste of what might have happened if Mid-Barataria had gone through.
Correct.
And in that regard, then the models were not exactly flagging it, but the disagreements certainly were suggesting somebody didn't know everything that needed to be known. And there were a lot of failures that occurred then in terms of the things that should have occurred. Um, this is usually caught through a series of checks and balances. But as you started to say, Dennis, and I kind of moved a direction for a second, but let's come back to it. These checks and balances kind of got diverted, bypassed even. Um, what was happening? Do you have an example of what was going on there?
Yeah. So the first thing that happened was in Louisiana, by the way, there was a constitutional amendment regarding the master plan and the projects in the master plan.
Mhm.
They called integrated protection and restoration projects. And basically, it gave the state sort of almost a police authority to implement a project because it they wanted to remove politics from implementing an important coastal project that that could restore the land or the coast so that people wouldn't interfere with it. Okay, that was the virtue in the amendment. Okay, so when I got involved with the parish, I was actually working as an independent consultant for a CMAR group that won the Mid-Breton project, but was also competing with the Mid-Barataria for the Mid-Barataria project. And we were in between the two. And as I shared, I went to church with the parish president. And I
Mhm.
told him about these letters that he needed to write. One was for mitigation. He had denied the permit for them to go drill on the site, not because of his own feelings, even though he did have reservations about the project. It's because the parish council passed an ordinance prohibiting the permitting of any diversions in Plaquemines Parish. And that had been on the books since 2014. This was now 2018. All he was doing was enforcing the ordinance as the administrator of the parish. Well, he wrote the letter. First of all, denying the permit created a bunch of outcry
I bet.
from the from the proponents of the
Yes.
project, and so he asked for a meeting at his office, and Plaquemines Parish is very rural oriented,
Right.
fishermen and farmers and all that. So they all came down and met with him in his office. And while they were meeting, they sent state troopers to the site with the drillers without a permit so they could drill
Yeah.
under protection of the state troopers. And I tell you, and during NEPA, which I'm old school, I'm 60, and the first job I worked on that was a NEPA project was in 1990, and it was a third party EIS, much like this one. I had never heard of anybody doing such a thing like that
Oh
during
no.
NEPA
Yeah.
because it's NEPA is almost like that's sort of that's the negotiation that you have with the public
Right.
and the stakeholders about the project.
Right.
So they were using police force to do this. And I just turned to the parish president when I saw him next, and I said, I'll write every letter you want me to write for you. I think that was wrong. Earlier that year, they had passed the Bipartisan Budget Act of 2018 in Congress, and they stuck a waiver in that bill, it's a budget bill, to waive the project's requirements to the Marine Mammal Protection Act. So that was another thing that was very disturbing, that a project that was deemed as a restoration project had the potential of killing all the dolphins in the Barataria Bay, which is why they filed for this wait.
I was
What
gonna say,
happened
it
was
wasn't that wasn't unknown. It was the fact that they suspected that was the case, and so they took the prohibition or the impediment from moving forward because of that out of the way.
that's correct.
Yeah,
And they knew for years, and the fishermen brought it up quite a bit
I
because
bet.
the fishermen understand, that's dolphins are very much a part of their world in their
In
in
some
their
ways, the canary in the coal mine for them.
correct.
Yeah,
And that could be a nuisance to many people, but who who would want to knowingly want to kill a dolphin?
right.
They chase fish away, they do,
Yeah,
but they're intelligent, sensitive animals.
right,
And so with that said, and that's the backdrop, they did go to NOAA and try to get what they call an administrative waiver. And they had a bunch of NGOs that were funded by the Walton Foundation supporting them to go for this administrative waiver. And they wrote memos and went to DC and lobbied for that. Well, NOAA indicated they couldn't justify an administrative waiver. So that's within the purview of the agency.
right,
So that's when, and they also, these NGOs were trying to get other NGOs to support the initiative. But when they went to the congressional waiver route, they lost a lot of support in the marine mammal NGO world, including the Marine Mammal Commission and the National Marine Mammal Foundation and a bunch of other NGOs that were not advocating for the project because they did not see any logic in killing these dolphins. So they wanted the dolphins protected. Well, that's like a leg on a stool, as I've
right,
discussed. And if you knock that leg off, you it could ultimately be to the demise of the project. You would think, oh well, the the Marine Mammal Protection Act was going to actually be an impediment for the project, but actually it's a guardrail.
right,
If it would have been in place, they would have had to design a project that was not oversized, and they probably would not have been stopped as they have been. It would have been right sized because it could not have killed any dolphins. So that is one of those things that came back around and boomeranged, I think. So that was one thing. The other thing was about the building permit, a common building permit that every county and parish, every municipality in this country has been given authority by FEMA through the NFIP. If they're a participant in that program, they have to have the floodplain manager sign off on every building permit because they do not want you to cause increases in water surface elevations. Well, the fact that they felt they had this police power, they didn't file for they filed for that drilling permit, but they never filed for the building permit as part. and that was not included. They ignored the letters that were written. I ended up writing 30 letters,
Well,
and I cited the ordinance. And they ignored this requirement by the parish. And that was another check and balance. Because diverting 75,000 cubic feet per second out of the Mississippi River into the Barataria Basin would have increased the water surface elevations by more than a foot.
ooh,
So, so that creates a whole nother layer of review that got bypassed.
that's wild. That's wild. Um, let's move over into just briefly this focus on doing a diversion structure. The idea of diverting water that's got sediment to try and rebuild the land. Uh, you and I both know there's other ways of making that happen. I live along the Tennessee Tom Bigby Waterway, worked on 10 Tom, and as such, have a maybe a little different perspective as you do. You want to share with our visitors, our guests, our listeners, what other ways are to try and reestablish or replenish um, land in an estuarine environment such as this,
Yeah,
wetlands areas such as this?
I think, and they do have some uh, outlets. They have Davis Pond, which is a diversion. They have Carnarvon. They have some natural crevasses. Every estuary needs riverine water in it. It's a mix of both the Gulf water and the riverine water.
Hmm.
So the problem with these large diversions, whether it be a flood relief outlet or a restoration project, if it completely evacuates the entire water column of the estuary, it's going to be very impactful to the estuarine
Right,
system.
right,
So a smaller diversion that has a smaller volume of water along with mechanical movement of sediment like a dredge. So that's where they're dropping back to is a medium diversion with dedicated dredging.
yeah, and
And they could have, after the BP spill, there was a lot of money in these trust funds, and they could have made an agreement with the Corps of Engineers, who has to dredge that river every year
right,
to maintain the navigation on it,
and
to place
and
that
the hundreds of
material in
tons
the
of
marsh.
sediment that they pull out when they're dredging, and it's
Right. It costs
exactly
money.
yeah,
It costs money to if when the river's being dredged for navigation purposes. There are several ways to do it. One is they could just waste the material and let it go downstream and out into the Gulf.
yeah,
One is they could that's that that's from a cutter head. One is they could do a hopper dredge and then drop it in the hopper dredge disposal area at the head of passes
yep,
or offshore. And they just, they sail or transit this vessel and they turn around and come back. But what we need in Louisiana is to move the material out into the marsh. And we
yep,
need to do that in a very wise manner and cost effective manner. And we did have a very large amount of money. We still do. Right now, they're talking about doing these long distance pipelines and these long land bridges, 20, 30, 40 miles across the marsh. And it's pumped sand from the bottom of the river.
yep,
And nothing stronger than that uh, to build on. That's how we built the urban part of the metro area of New Orleans. Basically, all of the sand that came onto somebody's house, under their house, and on their lot came from the river by truck. So a lot of Jefferson Parish was marsh, and it was basically reclaimed, even parts of New Orleans. So it's another old method that should have been considered in the planning of this project. You have to look at these pitfalls, and you got to look at
you got to look
uh,
at the cost benefit ratio that you mentioned earlier.
yeah,
What's the cost? What's the benefit? And some of those benefits are a little more intrinsic, a little more difficult to put a dollar value on, and the cost maybe a little easier to put a value on. I know in our case on Tentom, they're using hydraulic dredges and pumping out of the channel. Of course, we're not dealing with the Mississippi River, in both in terms of depth and width. So we move that material out. But what that's done is create a supply of sand that effectively shut down all the commercial sand pits we had around here. You just don't need them anymore. Um,
Right.
so there are technologies that allow you to achieve this without mass flooding of estuary areas
That's
or
correct.
marsh areas, and the degradation that occurs as a result of that. And as you said, let's be honest. Of course, just simply moving the dredge material, there's issues with sediment and turbidity that can cause environmental damage if not done right. So you've got to monitor all that. So there's not a simple fix, but there are better fixes that are better than others. Let's head over in a different direction a little bit and talk about some construction alternatives with regard to impact. One of the things I noticed about Mid-Barataria in the early days when we first started talking about it was that, and this is what I always lifted up, was that for the billions of dollars that were going to be spent, the maximum impact was going to be achieved after maybe 8 to 10 years. That impact was going to be maybe 10 to 15% replenishment of the soil. And then in another 10 to 15 years, all of that replenishment will have been gone. That the whole methodology was to solve a short term problem rather than figuring out a long term fix. And that just seemed like to me at least, a real waste of money, especially at the cost of the environment. But there has to be better solutions. There have to be all other alternatives. From your perspective, what maybe one or two of those might have been?
Well, I think that the estuary does need river water, and I think even the fishermen agree with that. It needs a good mix, a well-balanced mix of river water with the Gulf coastal waters. But I think dredging, this gets back to the NEPA document. They did not include dredging in the EIS for Mid-Barataria. It was not considered in the alternative analysis. Only this site was considered in the alternative analysis. All of that really is not a benefit. And I think that the people that were involved felt that they wrote a purpose and need that matched what they wanted to get built, and it restrained them from doing true alternative analysis. I think that they used to say a lot in these public meetings, you can't dredge yourself out of this problem. What what spurred on the whole third modeling effort was that the diversion, other parts of the diversion that need to be known. It only had about 9 feet of head, meaning when the river can only get so high, okay?
Yeah,
Because if there are other triggers, it has to open up at Bonacary if it gets above 17 feet at the Carrollton gauge, and they're never to allow more than 1.2 million cubic feet per second uh, to for it to go past that gauge.
right,
So they're triggers, operational triggers for the spillway. So even at the max, it's at 9 feet above the bay. The bay has its own water level. So when they're in their modeling, when they opened up the project into the bay, it would build up material on the outfall side, which then would change the head, right?
right,
You would have then backwater problems.
right,
And so that's why they ran this model to figure out how much it would cost to keep the material out of the channels to keep the diversion moving. Okay, so there we are back to dredging again, and that should have been foundational in the alternative analysis. We were not going to ever get out of having to dredge.
right,
So I think that that was a flaw in the analysis. The other thing about you mentioned about the benefit of the land building under the original concept was that uh, they had a sea level rise projection. Going back to the head,
right,
minus the land forming and the rising of the water on the outfall. If if sea level was rising, at some point, if it reaches the same equilibrium as a river, it won't flow. The diversion won't flow. That's why it was a 50-year design life. So the first 10 years are where all the really the first couple of years is where all the estuarine impacts occur.
Yeah.
But they say the dolphins, might have taken 10 years to completely extinct the dolphins in the bay. And then you have some land building over the next 20 years, and then that starts to decline because of sea level rise
Yeah.
in their models. So this really, it gets back to what we know is old. It's an old way, and that is to lay a foundation with dredges and then use the river very carefully to restore what you have used with the dredge. And I think that is the way to do it.
Yeah. Well, I think the moral of the story is, particularly from an engineering perspective, though certainly there are a lot of forces on this project outside of engineering. But from an engineering perspective, you never want to decide on what the solution is and then force your analysis to justify your solution. It's not engineering. The engineering
Right.
process is you do the analysis and then the solution is derived therefrom. And when the models
Right.
didn't coincide early on, the analysis needed to continue, the work needed to continue at that level so the engineers could then make an analysis as to what should have been done or what could have done or should any of thing been done. And at the end of the day, the engineering process, the scientific method, was kind of thrown off to the side, and opinion, perception, motivations other than maybe just trying to fix the problem uh, came into play, and you ended up with a something that almost didn't get stopped. But as you said
That's
at the
correct.
outset, it did get stopped eventually, and so here we are. Doesn't mean that somebody won't come along a few years from now and try and start it up again, but maybe better heads will be engaged at that time if it does.
It
Uh,
does create a very conspiracy type feeling when people aren't listening.
yeah,
Really is about not listening. It's not about conspiracy as much as it is about not listening. And these red flags were opportunities for them to make changes,
yeah.
and they 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 seem to double down.
Yeah,
Uh,
exactly. Yeah, and that's again, that's another lesson for engineers. You have to listen before before you apostolize a solution or whatever. You have to be aware of the surroundings around you. Look for knowledge. Listen to what's
yeah,
going on. Listen to the people that know. In this case, if they'd listened to
the fishermen.
marine fishermen.
Yeah,
They'd had flags that would have gone up very early, and maybe they did. But the problem was the motivation was such that, again, going back to removing the Marine Mammal Act or
right,
sidelining it, uh, maybe they were listening, but they didn't like the answer they were getting. So
correct.
it's not just listening; it's also processing. And but from an engineering standpoint, it's important for us to maintain our integrity and our acknowledgement that we're in this business to protect the health, safety, and welfare of the public, and that welfare part also includes the environment. The welfare of the public is the environment in which they live and they depend, and we have to step up and be willing to do that, and you did, and I congratulate you for that. Your dedication to protecting the health, safety, and welfare of the public, and I mean that in every regard. The fisheries, the habitat, the mammals, the water quality, let alone what was going on in the river itself. And through your efforts and others like you, um, things were achieved, and that's great. Dennis, we're completely out of time. I can give you 30 seconds if there's anything you want to share, and
Well,
otherwise, I'm going to have to bring this thing to a close.
I, I just would say that thank you for that acknowledgement. And it was a scary time, but we do have to stand up for what is right, no matter how many people may criticize for doing the right thing. But you still have to stay strong and do the right thing. And that would be my message to all your listeners.
Well said. Absolutely. I mean, again, it's our responsibility to do that in the face of sometimes opposing opposition.
Yep.
And again, thank you for doing what you did. Folks, again, thank you for joining us for another conversation. As I say always, I hope that you found the time you've invested in this conversation to be educational, to be beneficial to you as a professional as you continue in this walk as a civil infrastructure professional, and that again, that time spent pays dividends in your career and in your life. So, with that, until the next time, uh, stay well.
Thanks for listening to the latest episode of